Hi, everyone. Welcome to STEPCON, the Science and Technology Educational Partnership. I'm Barish. I'm a professor of physics here at Riverside, and I have a great interest in technology and what you're learning. I think it's a fantastic opportunity for all of you, and I'll try to just give you reasons why. First, STEPCON itself is sponsored by by CERT, the high school virtual learning module. It's a high school virtual learning module, and it's sponsored by our hosts who are behind me. That unfortunately we're virtual, but this is the Bourne College of Engineering at UC Riverside, and also the Center for Environmental Research and Technology. The approach this week that you're going to get is really a hands-on introduction to the high technologies, some of the high technologies that are moving our society forward, that are where you'll be years from now. I mean, now in high school, you study mathematics, chemistry, biology, maybe physics, and you'll get to college and study engineering. All this is very academic. And this week, you get the opportunity to do something much more hands-on and much more introductory to where it all ends up when some of you, hopefully a lot of you, end up going into science or technology and engineering. So this week, we'll find that you'll interact and learn with learning modules and then hands-on experimental work. And the fields are a variety of ones that are really right there where we are moving the world and our society ahead from where we are now. The first one, hosted by Matt Barth, who's the director of CE-CERT, is on smart cities and transportation. So smart cities and transportation is a buzzword, of course, but it's a very important concept that now is being used in the design and making cities work. For example, in transportation, which you'll learn about by making it intelligent enough to satisfy the needs much better of the population. Interestingly, I personally have some experience with smart cities in Italy. I do a lot of my research in Italy, and there's two different places in Italy that are doing very advanced work in applying smart cities. One is a city called L'Aquila, which was near the laboratory I work in, which was destroyed by an earthquake about 7 or 8 years ago. And in rebuilding the city, they have a lot of attention to rebuilding it in a way that's a smart city, in terms of the transportation, the communication in the city, the interaction and design between the commercial part and the residential parts, and so forth and so on, the kinds of things that you'll learn. The second place in Italy, just happens, my experiences in Italy, is in Milan, where they had, some of you might have possibly been there, they had a World's Fair for about 10 years that ended in 2015. And now they're taking the land, a large piece of land in fairly central Milan, and redeveloping it into a residential, commercial, and research place with a research hospital, for example. And it's being done as a smart city with a lot of attention to the internal transportation modes, things you'll learn about this week, and so forth. So I think, learning about smart cities is one of the most forward-looking things you could do, and those of you taking that will learn about that this week. The second one, which also is an area that I have a touch with, is artificial intelligence and machine learning. That'll be hosted by Barish Galler. She's an assistant professor of electrical engineering and computing here at UC Riverside. And machine learning and artificial intelligence are an area that had great promise for years, a lot of hype about what it was going to be used for, but now we're there. So The tools that were needed to develop machine learning and artificial intelligence have really come into their own in the last decade or more. It's as many uses, everything from using them in old people's homes to transportation or, um, for example, autonomous vehicles, or even in sciences. I use artificial intelligence or machine learning to study what we call glitches, which is kind of what the device develops as background for doing the science we want in our gravitational wave detectors. So it's used from the most advanced science to kind of practical things for all of us. And you'll use Python, which is the tool that we all use to use machine learning on some nice examples. The third area I know a little less about is microgrids. And that's important and becoming more and more important because of the fact that locally, in any sort of local community, we're starting to use renewable energy much more than we did in the past. And renewable energy has this feature that it's intermittent. It gets a lot of it when the sun shines or the wind blows, and less at other times. And so you need some way to be able to handle the ups and downs. And a microgrid is a connection locally that uses these features to run everything locally, and then it has to connect to the bigger grid where when it has an excess, it puts power back into the big grid. And when there is less renewable power, it comes into the local grid. And so you'll learn and do projects simulating some microgrids, which is more and more going to be and is an important topic. Sudra Ula, who is an expert in this area, will guide this part of the project. Lastly, there's a clean air section. I think that's subscribed. It's got to do with using little devices and measuring air quality, something that we're all reminded of and have been in the last weeks with the forest fires in California, how important it is. And an expert in that area, and you'll again be hands-on, will be guiding that, and that's Nicole Cleary. So those are the areas. And all of you will have learning modules to learn about it, and you'll have projects that you work on. The projects will then be evaluated. The best ones will move forward to some final judging, and then on October 16th will be an award ceremony for the best work that we've done. That's all I have to say as an introduction. Take advantage of all this. It's a wonderful experience to have so young and give you some guidance, and absorb it, and most of all, have fun. Good luck. Bye-bye.
Hello, everybody. My name is Nicole Cleary. I am the Deputy Director at UCR CE-CERT, and I'm so excited that you're joining us for this learning module. It's going to be really cool to learn about how to put these sensors together and use them in everyday practices. These PM sensors can be used to track wildfires, see what your indoor cooking looks like, and potentially monitor diesel particulate matter in your area. Before we get started, I did want to introduce a couple of our team members. First, there will be Dr. Ivey. Dr. Ivey is a faculty here at UC Riverside and specializes in low-cost monitoring and community disbursement. And we'll also have a recent graduate from UCR, Ivan, talking about the project. And finally, our sponsor from the California Air Resources Board. Hope you enjoy.
Hello, I'm Dr. Sunni Ivey, Assistant Professor of Chemical and Environmental Engineering at the University of California, Riverside. I am also an affiliate researcher at CE-CERT in the Atmospheric Processes Group. My research focus is providing data-driven evidence to support the development of effective air pollution mitigation strategies at the personal scale. Now more than ever, it is important to understand air pollution because history and scientific evidence shows that Black and Brown communities are at greater risk for air pollution exposure, which leads to a number of adverse health complications. So, your interest in air pollution will enhance a growing group of citizen scientists, and your input is very valuable for advancing our knowledge of community-scale air pollution impacts.
Hello everybody, hope you're all doing well. My name is Acquaah and I am a researcher at CE-CERT and I'm a recent graduate of UC Riverside. Why I chose engineering, it's kind of a long story, but I started as environmental science. I started off as environmental science and I met someone, a professor, who encouraged me to try engineering because that was where the money was, for one, but also that's where real change can happen. And so I switched majors around my second year to environmental engineering. Along the way, I also worked at CE-CERT in my undergrad, volunteering for an air quality project. And that kind of solidified for me that engineering is what I wanted to do. This project, it teaches air technology, air quality technology, and air quality science to high school teachers and high school students. And for me, that was the ticket. It really allowed me to bring out the community service aspect of what I wanted to do with my career and not lose that technical side of still learning about technical things and applying my engineering knowledge. And yeah, stay safe everybody.